The bottle of water sitting in your cup holder right now represents one of the most confusing economic transactions in the modern world. You likely paid somewhere between $1 and $2.50 for it. If you bought it at an airport or stadium, you might have shelled out $5. Yet there's this persistent statistic floating around the internet, repeated in forums and viral infographics, claiming that bottle costs a mere 5 cents to produce. When consumers hear this, the reaction is usually moral outrage. We feel scammed. We feel like victims of corporate price gouging on a resource that literally falls from the sky. But simply calling it a ripoff is an intellectual shortcut that prevents us from understanding how the industrial world actually works. The 5-cent number isn't verified by audited financial disclosures, but it points to a truth that the beverage industry prefers not to discuss. The liquid inside that container is, for all financial purposes, close to free. So if the water costs almost nothing, where does the other $1.95 go? To answer that, we have to stop looking at bottled water as a beverage and start looking at it as a service. You aren't paying for hydration. You're paying for a massive, energy-intensive distribution machine designed to overcome the physics of weight and distance. Today, we're going to dismantle the price tag of a single bottle of water. We'll trace the money from the municipal pipe to the plastic resin market, through the energy costs of reverse osmosis, and into the massive marketing budgets that convince you to buy one brand over another. We'll explain why water is one of the rare products where the packaging can cost dozens of times more than the contents, and why one of the most expensive components of the water you drink is often the truck that brought it to you. This isn't a story about greed, it's a story about logistics. Let's begin with the raw material. Brands like Aquafina and Dasani source directly from municipal systems. They don't hide this, it's right on the label. But the financial implications of that sourcing are staggering. We have a verified data point from Harrisburg, Pennsylvania. In a case examined by Consumer Reports, records showed that PepsiCo paid the city approximately $467,000 for 51 million gallons of water in 2017. Do the math. That breaks down to just under 1 cent per gallon. To put that in perspective, the amount of raw water inside a standard 16-ounce bottle costs the manufacturer about 1/10 of a cent. In the world of manufacturing, this is a rounding error. It's effectively zero. If you're holding a bottle of purified water right now, the value of the liquid itself represents less than 1/10 of 1% of the retail price. If you poured that water down the drain, you'd be losing almost no financial value. So the first real cost layer isn't the water, it's the vessel. The price of your water is directly tied to the global price of oil and natural gas because that's what the bottle is made of. Industry data suggests that a standard empty 16-ounce plastic bottle produced at massive industrial scale costs between 10 and 20 cents to manufacture. This includes the cost of the raw resin, creating the preform, and the energy required for the blow molding machine to expand it. We looked at that preform stage closely in our episode on plastic shelf life. This creates an immediate economic inversion that feels almost unique to this industry. The packaging costs exponentially more than the product. Imagine buying a sandwich where the bread costs 10 cents, but the wrapper cost $4. That's the economic reality of bottled water. But a hollow bottle isn't a product yet. It has to be filled. And this is where things get interesting. You might assume that filling a bottle is as simple as turning on a tap. In a modern high-speed bottling facility, it's a high-energy industrial process. The water must be treated to achieve what the industry calls engineered sameness. We broke down that concept in detail in our engineered sameness investigation. The municipal water enters the facility and gets forced through reverse osmosis membranes at incredibly high pressures. This requires massive pumps consuming significant electricity. Then it goes through carbon filtration, ozonation for sterilization, and remineralization. While the water itself is free, the process of stripping it down and rebuilding it isn't. Estimates for labor, energy, filtration maintenance, and plant depreciation add another 5 to 10 cents to the unit cost. We're now sitting at a production cost of roughly 25 to 35 cents. We're already well above the viral 5-cent myth, but we're still far below the $2 retail price. The next variable is the one that truly dictates the economics of the industry: physics. Specifically, gravity. Water is heavy. A single gallon weighs 8.34 pounds. A standard pallet of bottled water weighs over 2,000 pounds. A 53-foot semi-truck trailer hits its maximum weight limit long before it runs out of physical space. That single constraint drives everything downstream: plant locations, routes, retail pricing, and margins. You're essentially shipping heavy, low-value bricks. This logistical constraint helps explain why the bottled water industry is so regional. You can't profitably ship a bottle of water from Maine to California at scale. The diesel fuel costs can overwhelm the economics. This is why spring water brands often utilize a network of regional boreholes. They have to extract the water close to where they sell it, or the math stops working. Transporting that bottle from the factory to a regional distribution center and then to a retail store adds anywhere from 10 to 25 cents per unit, depending on the price of diesel and the efficiency of the route. If you buy a bottle of Fiji or Evian, which traveled across an ocean to reach you, that transportation cost skyrockets. You aren't paying for better water, you're paying for the fuel required to cross the Pacific. By the time the bottle reaches the loading dock of a retailer, the total accumulated cost is likely between 40 and 60 cents. Now we enter the realm of the intangible, the brand tax. Why do you choose Dasani over the generic store brand sitting right next to it? Why does Smart Water command a premium over Crystal Geyser? The liquid inside is often chemically almost identical, frequently purified municipal water with a standard mineral packet added. You pay the difference because of brand infrastructure. In 2023, Coca-Cola spent approximately $5 billion on global advertising. PepsiCo spent nearly $4 billion. These companies aren't just buying commercials, they're buying real estate in your brain. They're manufacturing trust. The blue tint of the plastic, the mountains on the logo, the words pure and crisp, these are carefully designed to make you feel safe. When you buy a branded bottle, you're paying a tax to help recoup that marketing spend. You're funding the billboard you drove past and the TV spot you ignored. The generic store brand costs less, not because the water is worse, but because it doesn't have to pay back a billion-dollar advertising budget. Finally, we reach the point of sale. And this is where the price can double. Retail margins on bottled water are often high, especially in convenience channels. A convenience store or gas station typically marks up bottled water by 30 to 50%, sometimes more. Why? Because they're selling you cold. Refrigeration is expensive. Keeping a cooler running 24 hours a day consumes electricity. You're paying rent for that shelf space. But mostly, you're paying a convenience fee. When you're thirsty at a gas station, you're price insensitive. You aren't going to drive to a warehouse club to save 50 cents. The retailer knows this. The price reflects the immediacy of your need, not the intrinsic value of the product. This brings us to the grand calculation. And to be clear, this is an illustrative model to show the structure, not audited per bottle truth. Raw water costs essentially $0. Packaging runs 10 to 20 cents. Processing adds 5 to 10 cents. Transport tax on 10 to 25 cents. Marketing and overhead vary. Retail margins vary. The exact numbers fluctuate with oil prices, packaging contracts, channel mix, and location. But the architecture of the cost remains the same. You're paying for a plastic manufacturing process, a diesel-powered logistics network, and a retail service fee. The water is just the passenger. This cost structure helps explain the tap versus bottled multiplier that sounds so impossible when you hear it out loud. The average cost of tap water in the United States is about $1.50 for 1,000 gallons. If you took that same 1,000 gallons and bought it in 16-ounce single-serve bottles at a convenience store, it would cost you thousands of dollars. That's a multiplier measured in the hundreds or thousands, depending on where you buy it. Few everyday consumer categories show a gap this extreme. And that gap proves that bottled water and tap water are, economically speaking, two completely different product categories. One is a utility, the other is a convenience product with branding layered on top. Comparing them is like comparing the electricity coming out of your wall socket to the electricity in a AA battery. Wall power is cheap and unlimited. Battery power is expensive and finite. You pay the premium for the battery because you can't plug your remote control into the wall. You pay the premium for the bottle because you can't put your mouth under the kitchen faucet when you're driving down the interstate. However, this system has externalities that the retail price doesn't capture. Recent studies show you're essentially drinking microplastics and nanoplastics with every sip. We covered the scale of that exposure in our microplastics episode. That's a hidden cost transferred to your biology. There's also the environmental resource cost. Industry studies indicate that it takes about 1.32 liters of water to produce 1 liter of bottled water. That extra third of a liter gets used for washing bottles, cooling machinery, and plant sanitation. In a world of increasing drought, that's a resource tax that doesn't show up on the receipt. And then there's the waste. 1 million plastic bottles are purchased every minute globally. While the industry correctly points out that water bottles are only a fraction of the total waste stream and plastic is highly recyclable, the economic reality is that a lot of it still ends up as waste. We're extracting oil, refining it into plastic, shaping it into bottles, filling them with free water, shipping them across the country, and then burying the plastic in the ground. From an industrial systems perspective, this is wildly inefficient. But from a financial perspective, it's a money printing machine. So, is it a ripoff? That depends on how you define value. If you believe you're paying for a rare, pristine liquid collected by monks from a secret glacier, then yes, you're being ripped off. The water is often from a municipal source, filtered and wrapped in petroleum. But if you understand that you're paying for the ability to access safe, sealed, portable hydration anywhere on the map, from a vending machine in a hospital to a cooler at the beach, then the price makes sense. You're funding a massive infrastructure project that guarantees consistency. The price helps guarantee that a bottle of Dasani tastes exactly the same in Miami as it does in Seattle. That consistency is the foundation of the entire bottled water model. Achieving that consistency requires billions of dollars in technology and transport. The next time you stand in front of that cooler, scanning the rows of identical clear liquid, understand the transaction you're about to make. You're not buying water. The water is the free gift inside the box. You're buying the box. You're buying the truck that brought the box. You're buying the electricity that keeps the box cold. And you're buying the feeling of safety that comes from the logo printed on the side. The water itself? That's just the excuse for the entire system to exist.